I'm personally very excited. This is the first ever Secret Summit. It's long, long overdue, and I have to thank the foundation and everyone in the community who organized this. They've insisted on doing it before year end, and I think that was the right call. But it was an unbelievable undertaking. So first of all, thank you very much for everyone, and thank you very much for everyone who's listening in. And let me dig into it, right? So I guess the fair thing to say is that this is a special kind of talk for me, and the reason is that while I'm gonna touch a little bit about the basics and what we've done today at Secret, the goal is really to talk about the future. The goal is to talk about where we're going, what we've achieved, but mostly where we're going in the next 1 year, 2 years, 5 years, and actually a decade plus, because this is the kind of ambition that we still have as a community, and I have personally, and Secret Labs as a whole as one of the teams in the network. But let's start with the very, very basics. If you look at blockchains today and the state of things, then there are really three core issues that kind of prevent blockchains and Web3 from crossing the chasm, from going mainstream. And those are obviously scalability. That's what everyone works on today. The other one is privacy. I mean, if you're here, then you at least are a bit curious about that, and that is obviously our focus. And the last one is user experience. Now, I think we're at a turning point, right? Because in the last few years, all of the focus was put on scalability. And I think now the focus is shifting on privacy. And that is exciting because finally the ecosystem is mature enough to kind of tackle what I feel is the actually harder problem. I think privacy is a harder problem to solve than scalability, but it's equally important. And user experience, we'd all agree that user experience in crypto is not great. And we also would, my perspective is that we're not even able to solve it yet. Like to solve user experience, we first have to solve the first two problems, then we can move forward. But once we complete that triangle, then it's game on for Web3. So in our corner of the earth, we're focused on privacy. And the question I get quite often is, why privacy? Why even privacy at all? There's this misconception, and I get it a lot, where people are saying, I don't care about my privacy, I'm an open book. Some even go as far to say that privacy is just useful for criminals. Now, the obvious explanation there is that, look, privacy is a basic human right. We should not give up on our privacy. This is something that is fundamental to who we are and where we are. But with that said, this is still a very, very narrow view of what privacy is. Because as a matter of fact, privacy in my book and by our philosophy, and just by any example that you can see, equals functionality. And what do I mean by that? What I mean is that there's just a lot of use cases. There's so many things where we take privacy for granted. And even if we don't care about our privacy, we simply wouldn't be able to do those use cases without the system that we're operating on, without the digital system that we're using to have privacy as a first-class citizen. And there are infinite number of examples. One of them is, private e-voting or sealed bid auctions, or even games. I may not care about. I might be a poker player, and I may not even care about my own data privacy, but it doesn't matter. Like if people see my hand at the beginning of the game, there's no game, there's no poker game. And this is actually true for any game where you have like opponents and kind of like a player versus player or a team versus team kind of situation. And there are many other use cases like identity, like even MEV protection and censorship resistance, where people are now kind of like waking up to the fact that these cannot be resolved without resolving the underlying privacy problem. Now, maybe that sets up the stage and the motivation, but maybe let's spend just one slide about what we've achieved today. And it was very challenging to condense it to one slide. And there's like maybe 5 hours of content today that is going to cover that in more depth. But just very, very quickly, I personally feel, and I think many would agree, that what Secret has achieved in the last few years is quite remarkable. And the reason is that even today, after 2.5 years of being in production, Secret is still the first and only blockchain with smart contract privacy. It's the only one when you can essentially run any computation securely, like in a blockchain setting, but over data that is sensitive, over data that you can see, and you can define exactly what data you cannot see and what data you are okay with making public. And there's been tens of thousands of contracts utilizing those capabilities deployed by many, many teams. We'll hear from some of them today. And there's been over 1 million private computations made utilizing those abilities. And more, and maybe even a more impressive number is that those private computation, those contracts, they've handled billions and billions of dollars of value in those private computations. These are things that were not possible before secret. But like I said, I'm here to talk about what's next, less about like what we've done. And this is something that's been, let's say, in our head for at least 5 years. Even when we kind of were building secret in the very early days, this was something that was brewing. And we always said that eventually we'll get to a stage where we're mature enough to expand beyond trusted execution environments, beyond our current tech stack, beyond our current set of use cases. And I think that day is actually coming today or in 2023. So Secret 2.0 starts and focuses on a new set of technologies that we're going to integrate into Secret, but it then kind of expands onto other things like moving from a single chain model to potentially a constitution chain model where all of them are interconnected. And this is also, and this is something that I have to thank our amazing community. So together with the community, we basically internalize all of the many lessons that we learned at Secret about tokenomics, about what worked within Secret 1.0, what didn't work. And we kind of came up with a plan, which I think is much, much more effective going forward. Now let's focus on the tech first. And I'm going to try to keep it high level, but I do have to get to some basic level of depth. And I think this is important. But if you don't get all of it, it's fine. I'll make clear what the take-home messages are. So, when you look at private computation, when you look at privately computing stuff on the blockchain, the thing that immediately pops up in people's head is zero knowledge. And I think the first important thing is to address zero knowledge as an amazing tool, but also to acknowledge what's the current state and what is still currently lacking. So zero knowledge are an amazing innovation. They've done a tremendous, like an unbelievable advancement in the last 10 years. They've become from something that is really a theoretical tool that no one thought would be efficient enough for real world usage to something that is improving on an unbelievable scale and an unbelievable rate. And for a technology that was originally notoriously known or infamously known for being unscalable, it's kind of ironic that it's actually emerging as the winning solution through ZK rollups to the whole scaling problem of blockchains. That itself is an amazing achievement. And zero knowledge proofs are also great for specific use cases of privacy that involve a single user. But the common misconception is that they simply cannot solve privacy where you have more than one user present in the computation. And as many would agree, when you're thinking about smart contracts, and a blockchain, that's an environment, that's a multi-user environment. That's an environment that combines data from many, many users, potentially thousands of tens of thousands and more. But the point is that even if you just have 2 users, you cannot run a private computation over 2 users' data with zero knowledge. And I'll give you a very simple example. Imagine that you have a private auction contract. And you want to make sure that the contract checks who the highest bid is, but never reveals the bids even after the execution it does. It only announces who what was the winning bid. Now, I actually asked, okay, so first of all, this is a trick question. Like if you go ahead and ask and think about how you can solve that with zero knowledge, the answer is that you simply can't. Like there's no way. Zero knowledge by definition require you to join all of your data together, to send all of your data together to some centralized party or trusted third party. Maybe it's one of the users, maybe it's an external party, but that party has to kind of see all the data for everyone in together. You kind of have to trust them. Not kind of, you explicitly have to trust them. And I actually asked this several people working on zero knowledge proofs, and I got from several of them the answer that, again, it's a trick question, but the answer that you can actually solve it with zero knowledge proofs. You just need to maybe write a more complicated ZK circuit or a more complicated ZK system. And that is fundamentally wrong. And I think we as an ecosystem in Web3, not just in secret, but in general, like we should be very clear in educating the public on what the limitation of each technology is, because that's how we actually move and make progress faster. Now, this kind of builds to the bigger picture where, just like in the invention of a blockchain, it wasn't enough to just build a proof of work or proof of stake or Merkle trees to the solution. You needed a set of technologies. The same thing here. If you want to build a privacy-preserving blockchain that is like the best, then it's not enough to use a single tool. You actually need to use a toolkit. And the goal of Secret 2.0 is basically to take the most common classes of solutions in the literature from the past, like let's say 40 years, and compose them together in a way that kind of builds the best privacy tech stack. And on a very high level, just so people kind of get the basics of why you can't use a single solution. So we already touched zero knowledge proofs. We already said that if you have more than one user, then you gotta trust some data manager to see all the data, which is not a desired situation. And then when you use trusted execution environments, which everyone knows is what Secret currently uses today, then I do still think that for many use cases, it's fine. But if you have like more higher sensitivity data, or like you're okay with maybe taking a performance degradation, then you would actually want to probably combine that technology with other cryptographic building blocks like MPC and FHE and zero knowledge proofs. Now the question, okay, zero knowledge proofs alone, they're not perfect for these. T's maybe not perfect for these. I would argue they're better for the general computation, but still not perfect. So there's this crazy tool set called MPC, which stands for multi-party computation, and FHE, which stands for fully homomorphic encryption. It's kind of nice that all of these acronyms are three-word acronyms. I don't know if this is intentional or not, but anyway, with MPC and FHE, and I'm talking about a specific part of FHE, which is threshold FHE. At the end of the day, the trust model is that you don't need to trust like a single entity, like in the zero knowledge proof situation, but you do have to trust a network. So this is very similar to how a blockchain works. In a blockchain, you trust that the majority of the validators don't collude. And in MPC and FHE, you basically need to trust that, again, the majority of validators don't collude here as well. But there's a very distinct difference, and this is why we trust blockchains to work, and we can trust MPC FHE as it is. You can trust MPC and FHE as it is. Because at the end of the day, the attack vector is much simpler. In blockchain, like let's say in Cosmos, if 1/3 of the validators don't produce blocks, then the chain halts, and it's very easy to see who produced blocks and who didn't. So there's accountability, there's actions you can take. The system also breaks explicitly. With privacy, that's not the case. What happens is that those validators, they can just go off-chain, they can open a Telegram group, and they can just share their keys or their shares of their keys together, and they can de-anonymize and break the encryption of the entire network, and no one would know. There's no repercussions, there's no accountability, and it's very simple. And for that reason alone, combining MPC and FHE with T's that's probably the winning solution. And you also need zero knowledge proofs a bit, but the main components are T's combined with MPC and FHE, because T's make it very, very hard, extremely hard, to extract data from the enclave. Now you've just made it exponentially harder to break like the majority of validators in the network. They can't just open a Telegram group and share their data in the clear. Now, MPC is very broad, FHE is very broad, but the way we kind of envision this is in kind of two angles. So we envision this on the bottom-up angle, and that is the MPC angle. So instead of building general compute MPC, then what we're actually gonna do is we're gonna start to add like the lowest hanging fruit, the kind of like specific MPC technologies into Secret that actually enable the most use cases with the highest level of security and the highest level of performance. And that is actually something that, and we actually researched this a lot, and we realized that that specific first set of technologies is threshold cryptography. I actually envision the threshold cryptography specifically is gonna become a big deal in many of the blockchains. And I think Secret's goal should be to, kind of spearhead that effort in its own. Now, threshold cryptography basically does a simple thing. It allows, it only focuses on signatures, like signing transactions, and encryption, decryption, right? And when it comes to encryption, decryption, and signing, then the idea is that anyone can verify a signature that's still public. Everyone can encrypt data that's still public, but the private key itself, the decryption that uses the private key, or the signing that uses the private key, that's done in a distributed manner. So the keys are split across all of the validators. That is the MPC part. And then the key is never reassembled in a single place. You can produce signatures, you can produce decrypted values without actually creating a single point of failure. Now, when it comes to, let me give you a concrete example, because this may not be very clear from the get-go, but let's take private voting. You can do private voting on Secret today, and we've done it. But if you want to hear about a hardened version that uses cryptography plus T's, then the way it's gonna work is as follows. You're gonna write a private voting contract, and it's gonna look the same. If you've ever seen a Secret contract, it's gonna look very much the same. But that contract on the back end would essentially initialize a new key pair, a private key and a public key, but the private key would be shared by all of the validators as mentioned, and it never would exist in one place. And our users, as usual, they know the public key, so they can encrypt their votes, and the vote should be 1 and 0, say like 1 if they're voting for a specific contender or applicant, and 0 otherwise. And here is where you actually use zero knowledge proofs, because users, if you don't use zero knowledge proofs here, then users can arbitrarily cheat, right? They can encrypt a value of like 10 or minus 15, and you would never know. So this is an example where zero knowledge have to be integrated and are very effective, but they're just part of the solution. And then validators can just tally the votes as usual, because the encryption scheme is not a regular encryption scheme, it's a homomorphic encryption scheme. So this would actually work with the underlying cryptography changes, but from a developer point of view, this would look like the same voting contract that you see today. And at the time of revealing the vote, when the vote is done, then the validators can participate in threshold decryption protocol, where essentially they just decrypt the result of the computation, which gives you the end result, like each candidate, how many votes they got. And the important part is that you see it's the same user experience that we have in Secret 1.0, but this already combines MPC, zero knowledge proofs, homomorphic encryptions, and T's all in one to create a much better and much more robust system. And the goal is really to expand way, way beyond that. I'm done with the very technical piece, and now I'm going zooming out and going high level again. But the point is that, we're going to build all of these into Secret as well, but we also believe in this idea that's very natural for Cosmos, where you, instead of having like a single chain, over time, Secret would actually horizontally expand to a constellation of chains model. Now, these chains are going to be tightly integrated with each other in ways that benefit both, and Secret would be the gravitational center of all of these. So, like, for example, we're looking into a fully homomorphic encryption chain, and that chain would probably have some kind of interchain security light model between Secret and that other chain. And there are many, many other chains that we can think about. Some of them can be developed internally. Some of them can be supported internally by Secret Labs, by others. and many of them can actually be completely external. I think the only stickiness that needs to be important in the constellation is to make sure that any constellation chain shares the same privacy, private compute values, privacy mission that Secret shares. And now the last part that I want to talk about is what does this mean for tokenomics? And I really think that we came up with something that would actually have been much more optimal. Like if we were designing Secret from the get-go, this is what we would do. That's the idea. And the key features for what we came up with, and this is not my own word, this is like, again, I can't thank enough the dozens of people in the community who've commented and worked on this. But the main properties of this is that we want to enable growth. And the way to enable growth is by setting up domain-specific funds that propel that growth, that kind of, let's say, help Secret grow in the places where it had the most trouble growing. And then the others idea are that it doesn't matter what we do short term, within like a few years, inflation is gonna decrease, and it's gonna decrease not rapidly but gradually to make sure that this is something that is, easy for everyone to get used to. But at the same time, it's been done in a way that, which in my opinion is really important, that makes sure that stakers are always ROI positive, which means that they're never diluted by inflation. They always continue to outpace inflation in any year, even year one, even year two, short term, long term. Now, the new funds part is probably the most exciting one. The new funds portion is, I'd say, highly motivated by the successful Terra Developer Fund that the community launched about 6 months ago. For those who don't know, the community passed a vote that we proposed, but everyone luckily were in favor of, to basically help Terra developers that want to onboard or migrate to Secret to do so. And this was intentionally a limited 12-month program. And so far, that program has yielded amazing results, in my opinion. There are at least five approved teams, and these are very successful teams. They're all building. Some of them have launched. And we only had to deploy 25% of the overall funds to get them. And I find that as a success because it was very important for us to make sure that funds are not misused and that they're used properly. And I think the key portion also to understand is that those funds are milestone heavy. So at most 25% of that fund will be allocated for those teams, but it's done on a milestone to milestone basis, and it's going to be over time and only when there's presentable ROI for the community. And building on top of that, the idea is to launch 3 new funds. One of them is the Growth Fund. So the Growth Fund is this, let's say, Secret's version of like a Google X, a VC fund. A VC fund is like the wrong term. It's the kind of fund that would specifically target high growth, high value acquisitions, mostly related to the constellation chain model. So the idea would be to identify, fund new kind of groundbreaking chains like FHE chain and others that would get funding from Secret and align them with the Secret mission and Secret values and also Secret stakeholders. And then there's the developer fund, which is meant to be an extension of the Terra fund to all kinds of developers and all kinds of use cases. And the third one is the incentive fund, which is meant to assist primarily DeFi apps, but not only, in their first days, right? The idea is to give them some initial bootstrap incentives model to kind of help them bootstrap liquidity, help them bootstrap TVL, or help them bootstrap engagement in many other ways that we can't even think about yet. And I just want to kind of finish with what the timeline is for Secret 2.0. So this is the first time that we're actually revealing a concrete timeline for this. So we spent the last 6 months doing research into this, developing this with the community, and then bringing this to, let's say, the public domain about a month ago. And we're setting up another month for feedback. So if you go on chain and I'll share the link immediately, then that's the place you can read the full proposal. And you should comment on it, because the idea is that on January 15th, the window to respond closes, and we take all the feedback and we synthesize that into a white paper. And 10 days after that, Secret 2.0 proposal comes on chain. And that is going to happen in a little over a month, on January 25. And that is when Secret 2.0 clock starts to run. And that is when we actually start to deploy this amazing brand new vision. Now, what's your main action? So obviously get involved in the discussion. If you want to help more actively, just DM me on Twitter or Telegram, and I will point you in the right direction. There's a lot to do in Secret 2.0, and there's a lot to help. And maybe the easiest, but maybe the most important call to action is to educate others about Secret 2.0. So people know Secret today. Many people know Secret. Many people understand Secret as it stands today. But I feel that still very few people understand what Secret 2.0 is going to grow to be. And I think that is up to us as a community to actually spread the message and make sure that this is a vision that a lot of people can rally around.